No, we're almost out of time. Okay, here we go. We are going to solve this system. Is it okay if I do a 3 by 3? It'll take a little longer.
No.
X plus y plus z equals 1. 3x plus 4y minus z equals 13. Solve. Oh, I already said solve. Using matrices. Okay. So 2. Look how 2 is next to the x, 2 is next to the y. What's next to the z? So do we just leave nothing, or must we put a 0? We must put a 0. Notice how the equations are in alphabetical order. I'm putting in a 0 for something that's missing. Okay, then I go 1, 1, 1, 1. And then 3, 4, what's that number?
0.
Negative 1, 13. Before you start going to a lot of work to do this, please pay close attention to whether you got all of the numbers and signs correct. Okay. Now generally, when you're doing this, you want to start by getting a 1 in this corner here. So, step 1, get a 1 here first. Okay? Alright, so there's different ways you can get a 1 right there. You could actually take, one of our rules is to add 2 rows together, but you could think of it as multiplying this row by a negative 1 and then adding it to that row. So it's sort of like you're subtracting 2 rows instead, which is the same thing as multiplying by a negative and adding. So that would be one way of doing this. But I think a better way of doing this is the fact that all of these numbers are even. What could I do to turn a 2 into a 1 without adding? Just divide everything by 2. So I'm going to divide, or since one of our rules is multiply a row by whatever you want to multiply it by, instead of thinking of it as dividing by 2, I'm just going to think of it as multiplying by 1/2. Okay? Now since I'm just barely teaching you how to do this, I'm going to do each step carefully one at a time. Normally if I was doing this problem as my homework, I would combine steps together just to save writing and paper. Okay? So right now I'm going to just divide these. Oh, and I need to tell you about the notation used to do that. Okay, I have just created a new row 1. So the notation for what I just did is I created a new row 1 by taking 1/2 times the old row 1. So I'm using a capital letter to represent the new row and a lowercase letter to represent the old row, and this notation is telling me what I just did. What's the value of having notation as you go along? Why would you want to do that? So that if someone else is looking at your work, they can tell what you were trying to do. Please, thank you. And also, if you make a mistake somewhere, you can maybe go back and figure out what you did so that you can figure out where to start correcting it. Okay? Alright, I'm going to go ahead, like I said, and write everything in one step at a time. So I'm going to go just write. So the only thing I did was this. Nothing else changes, right? Okay, the next step, or the next couple of steps, is turn these 2 numbers into zeros. And we can do that by multiplying and adding. So kind of like you would do with elimination method. Okay, what can I add to a positive 1 to get a 0? A negative 1. Do I have any negative 1s I could add to it to get a 0? No, but can I temporarily change that into a negative 1? Temporarily. I don't even have to write it down. I can just kind of do it in my head. So I'm going to create a new row 2 that is created by taking row 1 and multiplying by a negative and adding it to row 2. Maybe I will do 2 steps in one for this one. I think that would be easier. Okay, so I'm going to go negative 1 times 1 is what? See how I'm going to kind of just do this in my head, so watch carefully. Negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 plus, or times 1 is negative 1 plus 1 is 0. Negative 1 times 0 is 0 plus 1 is 1. Negative 1 times 3 is a negative 3 plus 1 is negative 2. It's very important that you're keeping these last numbers correct because those are your answers when you get to the end. But see how I temporarily multiplied row 1? Now look what I've done. I've just left it positive. It was just a temporary multiply by a negative to do what I needed to do with it. Okay, now I'm going to do row 3. What do you suggest? How about if we multiply row 1 by a negative 3 this time and add it to row 3? Does that sound good? Okay, so negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus 4 is 1. Negative 3 times 0 is 0 plus negative 1 is negative 1. And negative 3 times 3 is negative 9 plus 13 is 4. Do you see the similarities with the elimination method? Sorta. Here, I'll let you chat with people sitting near you to understand what happened.
Like for rows, they have to. Wait, so you just want to get zeros on both of the sides? Like on.
We're just working on those right now.
So like the notation just has to be whatever will make that 0?
Yeah. So this is your trail. This is telling me what you did. Okay. Moving on because the bell's going to ring, so we have to keep going. Now, our next goal, step 3, we want a 1 here, and then step 4, we want a 0 here. One of our rules is that we could trade any 2 rows. We want a 1 right here in the middle, and we want a 0 right here at the bottom. One of our rules is that we could trade 2 rows. What do you suggest? Yeah, I think we should just trade row 2 and row 3. Okay, so that's the next thing I'm going to write down. So 1, 1, 0, 3, and you trade the entire row. 0, 1, negative 1, 4, and 0, 0, 1, negative 2. Okay. The next step, but I've chosen an easy problem so that we don't have to do anything, is that we need to get a 1 right here. The way we would do that is by, if it wasn't already a 1, we could probably divide that row. Like if this was a 2, we could take the entire row and divide by 2, just like we did at the beginning, right? That would have also been how we would have gotten the 1 here if we couldn't just trade them, by actually dividing or multiplying by something to get rid of whatever number is there and turn it into a 1. Crap. Okay. Now you start working backwards and getting rid of these zeros. I will finish recording this and finish this problem later as a separate video. So there'll be one video that's what we just did and a separate video starting from this point. How does that sound? When everything's all done, these will be your answers. Like this would be X, Y, and Z, but not yet. Actually, look right here. What do you notice? Z equals negative 2.